Ontario student math achievement is slipping. For its part, Queen's Park is putting $4 million into upgrading the math skills of the province's teachers. But is that the formula that will improve math education and outcomes? Joining us now to help answer that in the nation's capital, Clive Packer, who's a concerned parent with a daughter in grade 4 and a son in grade 2. And with us here in studio, Annie Kidder, Executive Director for People for Education, and John Mighton, who is the founder of the JUMP math program. And we welcome everybody to the program. Nice to have you all here on this January day in the new year. Want to remind all of you that our producer Meredith Martin and our online editor Daniel Kitts, they're both hosting a Twitter chat right now, so chime in and tell us if you think Ontario's math curriculum is up to par, and use the hashtag AgendaTVO. And before we go any further, John's going to tell us what JUMP stands for.
It's Junior Undiscovered Math Prodigies.
Gotcha. And that's why you call it the JUMP program. That's good. Right. Let's share the scores with you. You guys know all these already, but we're going to share them with you and our viewers anyway. The Pisa math results. Here's graphic number 1. Shanghai, China tops the list. Quebec comes second. And then Finland. We've heard a lot about the Finnish educational miracle. Canada is next. And then as you get down into sub-jurisdictions, there's Ontario. And we're slipping down the list. We're now 13th out of 65 jurisdictions that were tested for math. The UK and the US coming in after that. How about the look at the past decade? And let's bring these scores up as well. The decline of provincial math scores over the past decade looks like this. As you look inside Canada, Alberta declines, Quebec about the same, Canada as a whole declining, Ontario declining, Manitoba declining, PEI declining over the last decade. This is of concern. Let's go around on this. John, what did you think when you saw these scores as they were released last month?
Well, I think we have to ask why they're slipping, but I think there's a deeper question. Even in the top countries, at least 30% of kids aren't doing very well, and very quickly moves to 50%. And that's been the case in Canada for years. We have to ask why even the best countries are teaching so little math to 30 to 50% of their population.
Annie, your view on this?
No, I think we have to look at it. I think the most important things to look at are ourselves compared to ourselves. So comparing ourselves to other countries, there are many factors that go in. I think John makes a good point that actually we need to look carefully then at who isn't doing well. But we've got to look in Ontario. Even Ontario's own scores in the EQAO math tests have also gone down over the last about 5 years. So we need to look. I'm not sure I would ever go as far as calling it a national emergency, what some people called it.
The former Deputy Prime Minister called it that. John Manley
yes,
said it was a national emergency.
I don't think it's a national emergency, but I think it's something serious we need to look at. But I agree with John that what we need to do is look at who isn't successful, and then we need to try to understand why.
Clive, when you saw the numbers, your view?
As a parent, I've been concerned about, math education for a couple of years now. So the first thing I would say is that I'm not really very surprised, although I am very concerned. And I think looking forward, the way that our economy is developing, we have a very technologically driven economy, and math skills will be absolutely crucial for future generations. And this is of great concern. We need to make sure we have a solid foundation in math.
John, there is a body of thought out there that says these are Pisa scores. It's one way of measuring things, but it's not the only way of measuring things, and it may not even be the best way of measuring things, and therefore take a Valium. What's your view on that?
That's a really complex question. It is a good measure, and in math it's pretty easy to measure some performance, but we also want to measure problem-solving deeper things, and also we want to measure, I think it's a great tragedy that kids don't love math. And I've seen kids cheer for math, beg to do math at recess. Kids are born with a sense of wonder, and they love solving puzzles and making connections, and they lose that through failure. So we also should be looking at what other losses are that come from not teaching math well.
Do you think these numbers, I guess on the question of before, the fact that they're going down, okay, but it's not the sum total or the only way to measure how well or badly we're doing in math. Therefore, Is it? It's not a national emergency, you've said, but
well, no, and I don't want to belittle that it's an issue. I think that it is a pretty good way of measuring how we're doing in math. I think what's really the other thing that's important is that it's not the only way of measuring how well our schools are doing.
Exactly.
That's very important, and we need to be careful. I mean, and one of the things we've been doing over the years is saying we have to be careful that we haven't kind of narrowed the definition of education by only looking at math and reading and writing. And I think that we have to, I think the thing that's always hard about these conversations is there's not one solution, there's not one problem, there's not one, quick silver bullet that we just need to change this. And the love of it is a really important piece. So as I was coming here, and I just talked to my daughter and said, I'm going to use you as an example. And she went, you always
which
do.
daughter?
The younger daughter, who's the same age as John.
21.
She's 21. She's in university. She's taking advanced statistics. Grew up in an artsy-fartsy family where I thought, and I want to take some of the blame for this as a kind of generation where it's like I'm not a math person. This is part of what John talks about. So the assumption was it's like we don't like math. But Katie, in fact, loves math, and loves now doing advanced statistics, but she didn't take math in grade 12. She still doesn't know her times tables, but she has a deep understanding of mathematics. So we, again, it's good to look at score, it's good to have data, and it's good to look at it for what you can use it for, but what's important is unpacking it and looking at it in all the complexity.
Is she going to speak to you again now that you've told all our viewers that
she said, don't say I can't do the times tables.
And you did.
And I said, so, what's 6 times 9? She went, oh, I don't know. And I went, okay.
Clive, tell us about, I guess I want to know the first piece of evidence that you saw which raised for you a huge question mark over how well your kids were doing in math.
Okay, the first thing that happened for us was when my daughter was in grade 2, and she would bring homework home. At the time, it was maybe adding two-digit numbers, so maybe she'd be asked to add 11 and 13. And she didn't have a clue how to even approach the problem, and I had known from my own childhood that there were different trends in math education and so forth, so I didn't want to just teach her the standard, what we might call the standard algorithm, without checking with the school as to what they were doing. Went to see the teacher, and this was my first kind of exposure to this idea, and the teacher said, we don't give them a procedure, we just expose them to different strategies and encourage them to find their own way of solving the problem. And for my daughter, that just left her completely in a spin. She was scared, she had no confidence, she had no idea how to approach the problem. She needed some guidance, and it didn't seem as though there was any guidance coming.
So her relationship to math gets off to a very rocky start. Has she recovered since then?
Yes, she has. Partly, through us working at home and teaching her some tricks and algorithms and techniques that she could use. And also, I have to say, as she's moved through the system, we've been very, very lucky with the school and the teachers that she has. They're excellent. So she is making good progress. But that was my first exposure to this, and that was my concern about this approach to teaching math, is that it can leave children potentially with a lack of confidence because they don't know how to start to move forward.
So let me see, she's 9 years old now?
Yes.
Does she know her times tables, unlike Annie's daughter?
She's starting to. That's largely down to us as parents, although again the teacher that she has this year is what I think she would self-describe herself as a little bit old-fashioned, and is helping to instill that. But it is not required in the curriculum. It's not required that she does know her times tables.
Huh.
She's in a situation where she does, but it's not required, and a lot of schools are not teaching it.
Well, now let me get to what I think may be the core question here, which is, are you doing the old-fashioned rote method to teach her the times tables and math and so on?
I wouldn't say we're doing rote, and I remember myself sitting in a classroom with 30 children chanting the times tables. No, we're not doing that. We're doing it very much just rapid fire. You throw a question into the conversation, what's 6 times 7? And just gradually try and through repetition of that. So yes, it's rote in a sense, but it's not quite the same as learning times tables as tables. It's just, here's a quick question, give me a quick answer.
Okay. John, let me get at this with you now, because I guess we're old enough, we learned rote, right? Standing up and doing it the old-fashioned way. There's something new, I gather, called discovery math, which is a different way of teaching people how to do that. Do you want to give us your best definition of what discovery math is?
Well, it's expecting kids to figure things out for themselves. You give them usually a big, rich problem, let them struggle with it, come up with different ways of solving it. And I mean, that's a positive thing to try and let kids discover or understand deeply, but there's a new research in cognitive science that suggests that there's drawbacks to that. So I wrote an article in Scientific American Mind in the September issue that summarizes the new research, and the problem is people don't know about that research. But we have to take it seriously. It's very well established, and schools have to start looking at it.
So the question then becomes, do we stick with discovery method, or do we start to incorporate aspects of rote again to get our scores back up and make people fall in love with math again?
Rote's not a great word because it suggests not understanding and boring. You can practice, and that's what the research suggests. Kids need more practice, but you can make that fun, like a video game if you raise the levels. Kids can also understand or use patterns. So the 3 times table, for instance, just write the 3 times table in 3 by 3 columns. 3, 6, 9, 12, 15, 18, 21, 24, 27. Look at the patterns as you look down the columns. You can memorize it really quickly. Same with the 7 times table. So there's patterns for all the times tables that kids love discovering, and they can memorize the times table very quickly. But you still need to memorize things. If you don't commit things to your long-term memory, then your working memory is filled up all the time just trying to remember them. And then kids struggle and develop anxieties and so on. So there's a balance we need. It's good to encourage kids to figure things out, but you have to scaffold it in manageable steps, give enough practice, and make sure they have the basic skills that they need to make those discoveries. And that's a rigorous thing.
Does People for Education have a view on discovery math versus rote?
No, because we're not experts in, John knows lots about math. And we don't have it in that way. What we do have is a feeling that what we have to be careful of is ever kind of swinging all one way or the other. So even if we look at the EQAO scores over the last, they've gone down for the last 5 years, they have, but the curriculum actually hasn't changed at all, nor is the teaching. So we have to look at what has changed then over the last 5 years and try and understand it. And I think what's important here is making sure that we don't sort of suddenly get into simplistic solutions that, we think, oh no, we have a terrible problem, and a kind of automatic, we need to either go back to something or go to all of something. And it's like the arguments people used to have, and still some of them do, about, as if there were such a thing, whole language versus phonics. There's no versus, and even in most schools, good teachers aren't all one or the other.
So it should be and, not versus.
Yeah, and I did have a hard time understanding a lot of the math problems. And what we do as an organization say is it's okay. It's not your homework, and you have to support your child to be able to do their homework themselves, be able to go and ask the teacher. But I'm with John on the, how do we build the joy in here, and what else do we need to think about? Like, did we in Ontario focus really a lot and put really a lot of pressure to try and get the literacy scores up? And did we miss things in math? Are teachers comfortable enough teaching math so that they're able to use a whole variety of ways of getting kids engaged, so that they know if a kid's feeling anxious because they're being left on their own? So, we definitely need to pay attention to it, but we need to be careful about thinking there's a solution.
I hear you, but Clive, tell me this. Did your kids ever go for any after-school kind of a thing like Kumon or a program like that?
No, we haven't done anything like that. I'm an engineer, so I have a mathematical background myself, so we can take care of things at home. We're lucky that way.
Okay.
I'd just like to chime in a little bit on the terminology, because I think a lot of people talk about discovery math or inquiry math, and that turns those words into pejoratives, and they shouldn't be that. Discovery and inquiry are excellent things. So from our perspective, what I like to look at it is very much whether it's self-directed or guided. And the question is, how much is the child self-directed and how much is the child being guided by their teacher? And that's the right balance that I think is what we're struggling to find right now.
So we don't know what the right ratio is for self-direction versus guiding at the moment. Is that right?
I think at the moment, the balance that's in the curriculum and that's happening in our schools is too much to the self-directed.
Too much. Go ahead, Annie.
And if I could say, I think that one of the other things that happened over the last few years is that there's been quite a lot of intervention, a lot of training, and a lot of support to help teachers know more about how to teach reading in exactly the same balance that Clive's describing. That you need to own some of it yourself. You need to be guided. There needs to be a combination. Some kids need my same younger daughter, who had, did have some learning disabilities, so she needed reading really broken down for her. So there is a possibility in Ontario that we really did put a lot of eggs in the literacy basket and not enough perhaps in the math one, and that's really where there's work to be done. I mean, there have been polls of elementary school teachers who have admitted that they're not that comfortable, quite a few of them, teaching math.
Yeah. Right.
Yeah.
John, but the reason I asked about the Kumon thing earlier is that I've seen these places, Kumon offices, and they're packed, which and they're I think they're mostly packed because most of these kids are not learning how to do math at school, and their parents are concerned.
Yeah, and again, the research is suggesting that if you don't have basic knowledge, basic facts, then you struggle to think conceptually. And so those tutoring programs are providing that.
But shouldn't we expect that level of knowledge
sure.
and
I just have
understanding
to
from the
interrupt
public
one
school
second,
system?
because the research also shows, for the most part, the kids are in those programs are actually doing well in school. So the vast majority of kids who are in extra programs or tutorials, or having tutors like that, are actually are the kids who are doing well at school.
Yeah, and
they're not there because they're struggling necessarily.
Is that right? The majority of the kids who go to Kumon do so because they want to do even better than
the
everybody
kids
else, not because they're
necessarily
struggling.
begging to go to Kumon, but yes.
Or their parents want them to, I guess. Yeah. Okay, I see.
If I might interject, though, I would
Yes,
say
go
the
ahead.
corollary of that is that the corollary to that is that the children who are struggling are not getting any extra help, and that's largely down to socioeconomic factors. And
Absolutely
what concerns me as a parent is we're in very great danger of developing a two-tier education system if we don't fix this at the core in the classroom, because then you'll have a situation where if you come from a wealthy home and or you have highly educated parents, then you'll get the extra help you need in math, and if you don't, you won't, and that's not fair.
Well, let's pick up on that then. And the reference off the top to the fact that the government's going to spend $4 million, as you suggested, to make literate but maybe uncomfortable in math teachers more comfortable with math. Is this likely to pay any dividends?
It's important, and it will pay some dividends, but I mean, teachers are my heroes, but at the Calgary Teachers Convention, to about 700 teachers, I asked why, when you divide 7 by 2/3, you can flip and multiply, and someone yelled out, because you get the right answer. And I've surveyed thousands of teachers, and they can usually they don't really know why that happens or give a very complex explanation. And it's trivial. You can explain it very quickly, and teachers are shocked when they see how easy it is. So at JUMP, we thought the only solution was to put downloadable teachers' guides on our website so teachers could learn the math, because there's not enough time in the day to train them in every aspect of the curriculum, not only how to understand the math, but how to break the lesson into manageable steps, where to assess, how to raise the bar to get kids excited. That takes years and years. It took us years to develop those guides. And so...
And are teachers downloading them and using them?
Oh, yeah.
They are.
There's like 100,000 kids in Canada now who use JUMP as their main classroom program.
Does it cost any money for them to download that?
No, you can download it for free or buy a hard copy. So we're a charity, so we made it available. But we realized we couldn't train teachers enough. And training is extraordinarily important, but you need to also allow teachers to innovate, to try new things, not keep doing the same thing over and over. And we need to develop resources that are tested and work and that teachers can have access to.
Annie, it's an open question, I think, in a Ministry of Education that spends $20 billion a year, whether $4 million on additional education for teachers to make them more comfortable teaching math can have an impact. What do you think?
I think it probably will have a little impact. It just means access to free PD to be able to do that. I think, as importantly, we're going to have 2 years of teacher training now instead of 1. Hopefully then there will be more time spent on learning as opposed to just learning teaching methods, actually learning content in that way. But I think we have to look at a bunch of stuff, because I have a feeling, I have no proof of this, I feel that we have to think about our own attitudes towards math too. And you've talked about this a lot, but and I'm not blaming parents really, but I blame myself for it's the idea, and you can see it in the media. Most media people probably aren't necessarily math. I'm not a math person. And a lot of teachers aren't math people. So we've kind of set up, oddly enough, because we have the world out there going, it's all going to be about technology. We need kids who could do math, where we have like another generation with an attitude of math is hard, math is boring, why, how will I ever use it? I mean, didn't do math so well. I use math all the time, every single day in the work that I do, deep complex math, but because I know how to learn, that I'm able to learn. So, you know, I can kind of remember my times tables, but most importantly, and I think still most importantly in school, if you can have kids who are excited about learning, who do know, but do get guidance and support and help how to figure things out, that they can still take advanced statistics and maybe not know their times tables.
Clive, how hopeful are you that $4 million is going to make a difference?
You know, any extra funding for education is always welcome. I don't think it's going to make a significant difference. Having looked at this issue over the last 2.5 years, there is a general trend in jurisdictions that have embraced what I would like to call the more self-directed model. All of those jurisdictions, without exception, are declining in their math achievement. And so I do believe it's fundamentally at the core, in large part, a curriculum problem. And the $4 million is very nice and very welcome, but I think it is a little bit of a Band-Aid solution, potentially.
In which case, if you wanted to not just put a Band-Aid on, but do some major surgery, what else would you be recommending?
I would recommend that we look at adjusting the balance of the way the curriculum is structured and move back to, I wouldn't say more traditional, but back towards a little bit more guidance, a lot more practice, and a better balance between what I would say is knowledge and skills. Because right now, we're very focused on skills. The curriculum calls for the child to be able to work out 7 times 7, not to know 7 times 7. And there are some things in math especially that it's better to know, because then you can move seamlessly on to the next level. You don't need to think about what you're doing when you're trying to factorize a quadratic equation. You don't need to be thinking about the multiplication that's involved in working that out, because you'll just have it at your fingertips. And that is very, very important. And what I've seen in my own kids is I would say that knowledge breeds confidence. If they know they've mastered something and they know they have that knowledge at their fingertips, then they're much more confident. And with confidence comes a lot more joy as well. Because if you don't have confidence, if you have fear, then you can't possibly hope to have enjoyment in doing math. Whereas if they have that baseline of solid facts at their fingertips, then they can move on to the discovery and the inquiry and the problem solving and take joy in doing that, because they're not thinking too hard about the basics. They've got that at their fingertips, and they've got the tools to solve the problem.
John, would you weigh in on that issue of whether or not it's more important to know what 7 times 7 is versus how to figure out how to get the answer?
I agree with everything Clive says. I think it's a balance. It's about 50-50 there. And
but there's stuff you just got to know, right?
Yeah, for sure. The automaticity, you can do it without, as Annie points out. It's just that the automaticity frees up mental space for other things. And the kids who don't have it are the ones who struggle. And they start developing anxieties and falling further and behind. So that's why it's so important. But it's also, and I agree about the confidence, we have to actually test programs to see how they affect the psychology of the classroom. We had one teacher who convinced her kids right from the beginning of the year that they were all capable, and they were a very average class with kids scoring in the 9th percentile. It's very low. 2 years later, they wrote the Pythagoras math competition, and 14 of the 17 got awards of distinction. The other 3 came close. We have to radically change our expectations of what kids can do, not just because we want them to execute the math or understand it, but also because it's a right. It's a right to enjoy math, just as it's a right to enjoy reading.
You know, and I just want to add one thing that again, as opposed to going, it's the, you know, especially, and it is unfortunate, it's discovery is the thing that's, you know, taking the blame for this. But if we look at Quebec, at the French language system in Quebec, where they are actually doing quite well in math and where their scores have been improving, they do use discovery math, but their thing has been the focus on teacher training, that they've actually been using it for a long time, that they've looked at things more in depth. So the level, the strength of the teachers in terms of delivering this kind of math and teaching anyway. I mean, it's a miracle that, you know, teachers teach, and, you know, I mean, it's a pretty amazing thing to do, but recognizing that has made a difference. So what's important now is not going all one way or the other, and I think we all agree, actually, you know, that it's making sure we've looked at it carefully, and for me now especially, that we look at who is struggling and try to make sure, and I love the philosophy of JUMP, which says everybody can do this, and, you know, we'll set the bar for everybody and get everybody there. But
49.
I think there's another issue we need to address. It's we need higher standards of evidence before we roll programs out.
Yeah.
So For instance, jump was evaluated in a randomized controlled study where the jump students went twice the rate of the control group. And so that's just a partial result, but that's a rigorous result, and you have to start taking those things seriously, and you have to make sure, and we're exposing ourselves to more and more studies like that. It's very risky, but you have to do it to make sure that what you're doing works. And
The
so,
math, forgive me,
Yeah.
the math I always have to deal with is a clock, and the numbers go down, and then they go to zero. And that's where we're at right now, unfortunately. Clive Packer, we thank you for joining us on the line from the nation's capital, and good luck with your 2 kids in grades 4 and 2. And we thank you for joining us today. Annie Kidder for People for Education, John Mighton, Jump, Math, making it fun. Thanks so much, everybody, for this.
Thank you.
thank you.
Support Ontario's public television. Donate at tvo.org.